Welcome to section 3.6. Today we're talking about the different types of triangles and how we classify triangles based on the angle measurements and also by the measurements of the sides. First we're going to talk about angles. There's three different types of triangles that we could have. This is again all in a plane. An acute triangle is a triangle that's made of three acute angles, so all of our angles are less than 90 degrees. A right triangle is a triangle with one right angle, but the other two are going to be acute. An obtuse triangle is a triangle with one obtuse angle, so again just that one big angle. Obtuse meaning bigger than 90 degrees. And the other two angles will be less than 90 degrees. They'll be acute angles. So from this we can tell that no matter what type of triangle you have to have at least two acute angles. In a right triangle we have special sides. The hypotenuse is always the biggest side of a right triangle. Again, these names only work for right triangles. So the hypotenuse is the side across from the right angle. So there's your right angle, and we can tell that by the box in the corner indicating right angle. And the hypotenuse is directly across from that. The two remaining sides are called legs. Sometimes they are congruent, sometimes they are not. We can also classify triangles by side. A scalene triangle is a triangle with no sides congruent. So all three sides of the triangle have different measurements. We could have something like a 5, a 7, and a 10. All three of those are different measurements. An isosceles triangle, and there's an important part of this definition, is a triangle with at least two congruent sides. So if it's got two congruent sides, it is isosceles. If it's got three congruent sides, it is still isosceles. Now, we have a very special name, though. If it's got three congruent sides, we call it equilateral. So a triangle with all sides congruent is called equilateral. And we can also call it equiangular because in this case, triangles, if the sides are all the same, the angles are all the same. Now I want to go back to this point here with the at least two congruent sides, because any properties we know for isosceles triangles are also going to apply to equilateral triangles, because they are isosceles, they just have that third side congruent as well. And the parts of an isosceles triangle, there are many different parts, four different types essentially. The legs in this case, if it's isosceles, are going to be congruent. So unlike a right triangle where the legs were not necessarily congruent, in an isosceles triangle the legs are the congruent sides. And in between those congruent sides we have what's called the vertex angle. Now the remaining side is called the base. So no matter where these legs are, they could be these two sides, and then this side would be the base. But because these two sides are given to us as the legs, then the remaining side is the base. At the base, the angles that are formed are called the base angles, because they're made from the base, and the other side is going to be the leg. So if you have a leg and a base together, that gives you a base angle. If it's a leg and a leg together, that's the vertex angle. Later on in the chapter, we will find out that if we have an isosceles triangle, that these base angles are actually going to be the same as well. So example 1, we want to classify the following triangle as scalene, isosceles, or equilateral if the perimeter is 45. So we got that word there, perimeter, which means add up all the sides, and they tell us what it is. So my strategy for this is going to be to add up all three sides. So I've got my 4x plus 3. I've got my 7x minus 6. I've got 15. And I'm going to set that equal to 45. And from there, it's a simple algebra problem where you can combine like terms. You get 11x plus 12 equals 45. Take 12 away, you get 33. X is 3. From there, we want to classify it based on how the sides relate to each other. So scalene, isosceles, or equilateral. We're going to take that 3 and plug it into here. So when you do 4 times 3, you get 12 plus 3 gives me 15. Do the same thing for the 7x minus 6. 7 times 3 is 21. Take away 6, 15. 15, 15, 15. All the sides are the same. I call it equilateral. Now notice I didn't call it isosceles. We had mentioned that equilateral triangles are also isosceles, but this is a more specific name. So the more specific you can be, the better off you are. Alright, one more example. We'll do a proof, and we'll see how isosceles triangles fit in with proofs. So we've got triangle ABC is isosceles with base BC, so there's the base. And if you notice in this given, they tell us where the base is, which implies to me that the other sides are the congruent sides. I also know that BD is congruent to CD. That's given to me. Eventually I want to show that angle B is congruent to angle C. And at this point I don't know any shortcuts other than proving the triangle is congruent, so we want to follow that process. So let me start off with the things past the givens. So I knew BD congruent to CD. Because of the first given, I knew that AB congruent to AC. And my reason is going to be the fact that I knew it was isosceles. So an isosceles triangle has two congruent sides. So take those sides that you know are congruent and mark them off as such. From here I have two pairs of sides congruent. I can get a third quite easily by using reflexive property. So AD congruent to itself. And that's the reflexive property. And then from there, looking at the triangle, I've got a side-side-side relationship on both triangles. So I'm going to name the triangles ABD, congruent to triangle ACD, and that's because of side-side-side. And then the angles, angle B is congruent to angle C. Once I prove the triangle is congruent, if I had to keep going, my next reason is always going to be CPC-TC. And that's exactly what I was trying to show, that angle B and angle C were congruent angles. The proof is done. So again, if it says isosceles and it tells you where the base is, which it will, then that's going to tell you exactly where those congruent sides are. The remaining pieces are the congruent legs.